Well, welcome everyone to this week's Community Office Hours. We're going to talk to you today about some recently released security packs. And let me go ahead and share my screen here. So, or am I going to have a big slide deck? The answer is no. I'm just going to dig right into the packs. And so in particular, over the last few months, a bunch of us have come out with various security relevant packs. I might be talking today about the CrowdStrike one and Imperva as another one. But notice over the last few weeks here, there's other ones like this InfoBlocks one, Windows Classic for sending to Exabeam, and various other ones here that are security relevant. But let's go ahead and dig into this CrowdStrike one. So this is available both on our pack dispensary, where you can just go to packs.cribl.io, go over here, download it, or also on the GitHub page while we still maintain that. Both of them are also there. Or when you're on version 3.4 or greater, you can just go add new from within Cribl once you're in the processing packs section. You can do add from dispensary, and you can select the one pack you want to install here and immediately get it installed just by clicking on install. It's great out here because I already have this one installed. But while I'm here, this is the CrowdStrike pack that I'm going to talk through, which has been relatively popular here over the last few months with a lot of demand for this. Let's go ahead and get into this. First thing we always want to do when we're looking at any pack, so if we go ahead and open this up locally here, is always go look at the README. The README is under settings. And in this case here, we have a diagram that explains or lays out everything that's happening within this pack, as well as just general instructions and why this pack exists and what you can benefit by leveraging this pack. In particular, there's a lot of unwanted events because CrowdStrike is very chatty, so why not drop those? A lot of other events that also have just a lot of fields that you're never going to search or report on. So let's remove those fields. And then in many cases, just because of the sheer volume of logs that are similar to VPC flow logs or NetFlow, why not aggregate those? So this is exactly what we're doing here with this pack. And the CrowdStrike pack also has some additional capabilities to help do some enrichment. And it all stems with the way CrowdStrike sends or makes their logs available. And by the way, this integration, this pack was primarily written for CrowdStrike FDR. That's where they will post all of their logs for your instance there to an S3 bucket. And then you will have access to that S3 bucket. They'll give you access to that S3 bucket to read all of the logs that are written to there. And then you can have Cribl process them and send them on to Splunk, send them on to Elastic, Exabeam, or your destination of your choice. Or potentially another S3 bucket as well that you own and control as the customer versus the one that CrowdStrike gave you, because that one only will keep the logs in there for 7 days. There's a couple of distinctions here between two kinds of logs that are relevant to this pack. So all of the real-time logs, they get categorized in this all other events here, but there's also some inventory events that will generally get sent once a day. And they will go to in their own directory inside this S3 bucket that CrowdStrike makes available to you. The purpose of these really all of these other events give you the ability to enrich all of these other events. And because of Cribl's share nothing architecture, we have to put this information that's going to be looked up, we have to put it, because of the way it's coming in, we have to write it somewhere. And Redis is really the ideal place to put all this information that we would use for enrichment. So here we have dotted lines to and basically reflect that this is an optional step. It's disabled by default in the pipelines, in the pack. but you can enable it if you have access to Redis or an AWS Elasticache or a similar from other cloud providers as well. Everything else basically falls into these all other events, and these are the streaming events that should be coming every second or every few minutes as they get written to the S3 bucket. And the way behind the scenes, just to kind of set the stage here of the workflow, at the route level, there's two pipelines here. There's one that is going to populate Redis with the enrichment, and then another one where all those streaming events are basically going to match. But within this pipeline, there is reference to chain functions in many cases here that'll basically filter for the different data sets. So in this case here, network events, they'll filter on network events versus DNS events. And then there's going to be another pipeline that'll further process that data down just for those types of events. And in the case of the network pipeline, or this enrich from Redis pipeline, those will actually be going out to Redis and reading this data that got populated from this AI master inventory data set to use that for enrichment, or in the case of network pipeline, use it for aggregation. So let's quickly go into what the pipelines look like. So first, we'll go to routes here. Notice here are the two routes. The first one that's disabled, that writes to Redis, all of the inventory data. If you have access to Redis or you have it set up, you can enable this. And everything else, basically, we're saying here, if it's anything outside of this data directory in the S3 bucket, map it basically to this pipeline. And this pipeline is this CrowdStrike general one. And once we go in there, this is where we can see now at the top, we're doing general processing of the events up to number 4 over here, where we first shape the event, make it just universal so that other functions can reference the fields in those first set of functions. Also, timestamps. In this pipeline, in the README calls out to also load an event breaker set of files. So that's the primary way for doing timestamp assignments. But I've also recently, in fact, yesterday, added this portion here to this pack so that if somebody did not do the event breakers correctly or they're not in place, we can still do some timestamp recognition and fixing. And then next is where the magic happens, where we start matching on various events. And in this case here, the first section, we're dropping events. We're dropping unwanted events. And it's using a lookup. So in this lookup file here, event simple name drop.csv is where there's a list of all the event simple name types that we can drop. And so let's go ahead and just take a look at that here real quick. So to do that, we go to the knowledge tab while we're still inside the pack, lookups, and then here's the drop one. We click on this. Anything that comes in with these event simple names will basically get dropped. And as you can see, most of them here in talking with other customers are really noise. They're overhead events mostly that nobody searches on. But if you are one of the few that does need to search on this data set, then maybe this raw bind IP4, maybe you want that, you can just remove it from here, right? Or if there's another event simple name that you want to add in here, you can also add that in here so that this becomes really a starting point for you. And I guess I forgot to change my comments. I guess I'll update those. But again, these are events that will get dropped. And back to the pipeline here. That's all basically enabled just with this one filter. right? This one filter is what enables this dropping to happen. And this was the reason we're able to specify raw event simple name is really because at the top here in function 1, we did this JSON parse. Otherwise, we wouldn't be able to do it. We'd have to do an extract function, a parser function with extract or something like that. Any questions from anybody before I move on to the rest of the pipelines?
Nothing in the chat so far.
All right. We also talked about enriching from Redis. So similarly, if Redis is in the mix here and you have your actual inventory data being written to Redis, you can enable this chain function here. And this basically will execute this inventory enrich from Redis. And I'll just quickly show that here real quick. I won't spend too much time in here, but here's where we've got various steps to basically look and see if data exists in Redis, bring it back if it does, and populate it, add it to the events. So this one group here, enrich from Redis, really has 3 options, and it calls out to enable only one of these 3 functions. Don't enable all 3. The first one is only going to get you the computer name field out of all of that massive lookup. And just so people see what's in this lookup, here's what it is in one of these events. And most of the fields that are in here, not all of them, get populated into this lookup in Redis. And so in this particular function, we're calling out to read only the computer name field and populate that into the events. Without computer name field, the only thing that you have to basically reflect a computer name is this AID. And who's going to be looking at that to do their searching? The next one here will get a couple of fields, computer name. If we go here, we'll just see computer name and OU. So it'll get 2 fields versus the last one is going to get everything, get all. So it's going to get everything that was written basically into the Redis key value pairs there. Everything's going to come back and get populated into the event as enriched data, if somebody wants to do that. So all 3 options are available to you, and then some other overhead there just for completing it out. So Redis can definitely be extremely useful, extremely powerful for adding this extra context that otherwise you won't get in your SIM without some other enhancements on the SIM side. And then similar here, we have chain functions for these various filters. Let's cover the DNS one because this one is a bit interesting here to get into. So we expand this. Notice we're filtering on DNS requests. Let's drill down to this DNS pack. And while we're at it, let's load some DNS request events here as well. So in this, through the help of Igor Gifrin, he and I came up with this, where we're basically looking at the domain name of the request that's being made, right? So when you're opening your web browser and you're going to some share site on the Microsoft.com, this is a domain name that it's doing a DNS lookup for. CrowdStrike is recording all this. CrowdStrike's agent is recording all of your network communications, all your DNS requests, all the processes that are running, what they're doing. It is capturing a whole ton of information. This is an output here of what the DNS event looks like. So what we're doing here is basically, let's go to the first one here. We're splitting this domain name out here, looking at just the top 4. So com, Microsoft, MP, DSP. If this is a match in a top 100K list of URLs that are that people go to, a lot of times security analysts don't need that. And so at least not from going directly to the SIM. They might still need it for threat hunting, so they'll put it in object storage, but for going to the SIM, they will want to filter it out many times. So with this filtering that we're doing, and then using this lookup over here, where we're looking up in this file, this majestic 1 million that we've imported into Cribl. And this majestic 1 million is bound by an open source type of a license. That's why we're able to incorporate it in here. And in fact, what does the file look like? Let's go over here, and here it is right here, the 100K. Notice it has just about 100K entries in there. And usual suspects with the top domains, but this is 100,000 entries that are in here. So we're doing basically a lookup against that file to see if the top level domain, if the second level domain, if the third level domain are all in there. If any of them in there, then let's flag this, and at the end of the day, basically drop those events. So if we go here to the out tab, and let's select here, don't show us dropped events. Here's now the list, and that reduced these events by 95%. 95% reduction just from that. All right. Any questions about this DNS one? And I have a comment that I got from a customer that I'll share with the team, but let's see if there's any questions about this.
Yeah, if you have a question, go ahead and put it in the chat. Nothing in there yet, Ahmed. You can also come off mute. Everybody's on mute by default coming in, but if you want to come off mute and ask a question, that's fine as well.
Ahmed, this is Kevin. Question about the Redis lookup pipeline. Is that, I'm assuming events that are going through that are also going through some of the other ones, correct? Sort of a hit in there and then moving on to see what else it matches.
Yeah, so the events, let me see if I got your question right. So the events are going, yeah, they might go, yes. If you're asking, would the events go through the Redis pipeline and potentially into the network pipeline?
Yep, that's what it is.
Yeah, absolutely.
Okay.
And so if we go back to the general, notice for the Redis one here that's disabled, the final flag is set to no, versus all these other ones, network, the final flag is set to yes with this F right here.
Thank you.
Hi, this is Nick Magalanis. The place, I hopefully have some time to go over this, but where you were talking about earlier, the AID to host name, can you go over that one more time? Sorry.
Yeah, sure. So what CrowdStrike does is they send their inventory events, as I'll call them,
right,
in a nightly into the S3 bucket,
yep.
And it goes into a data directory, right? And in there it has all this information about that includes the AID, computer name, and other information here about that system where the CrowdStrike.
Right, and it does not include the host name, right?
So this is the inventory event, so it does include the host name, but
okay.
Say like a DNS event, or let's look at the network events here. Network events do not have a computer name field.
Right.
Network events only have the AID field,
yep.
Right here.
So what is it that you did over in your pack to resolve that?
Let's go to this diagram. The first thing we have to do is take those inventory events and put them somewhere where we can use a lookup. So in this
okay.
case,
I got you. Okay.
Yeah, in this case, it's where we're using Redis. Why aren't we using like local lookups and lookup files instead in Cribl? The reason is you have many workers, right? And each worker process is running independent of the other with Cribl's share nothing architecture. And so it's the feasible way of basically writing a lookup that all of the workers are aware of is by leveraging Redis to put that data in there. And then now that data becomes available to be enriched when other events that don't have the computer name field in them basically come through through the list. Did that answer your question there, Nick?
Yeah, I was aware of the fact that in some of the events I did not see host names. That was one of the biggest things that we saw without this solution. So I just want to make sure that I was understanding correctly that it was able to be resolved with this.
Yep.
Yeah, Ahmed, and you're doing that because otherwise you'd probably have to have some external process like loading CSVs into the workers via API and all that kind of stuff, right?
Yeah,
exactly.
Something else. Yeah.
Exactly. Yep.
Cool.
And then here also the other benefit is you're doing it at the time the events are being ingested, right? That this enrichment happens versus, with other solutions where it would have to be done after the fact, either at search time or, through some other lookup like we're talking about.
Okay, thank you.
Sure. All right, so 1124. Let's get into another one here that I think people would also get some interest out of. So let's go back here to the top level. So the routes, right? Let's go to CrowdStrike General. That's where we have all these chaining to different functions, or not functions, chain function to different pipelines. Get the terminology right here. Let's look at the network one. So this is another one where Redis is also an option. And here's the network pipeline. And let's load some network events here just so people see what they look like. And so what we can see here, even though these events have local IP address of 0 and remote address of X, right? Here's what they're doing. They're going to this port. So that's a DNS. They're basically doing DNS lookup. And any IP communication like this is registered by CrowdStrike and goes into a different set of events than, say, the DNS lookup events that we were just looking at a few minutes ago. So a lot of noise. Wouldn't it be nice to be able to aggregate these and say, let's aggregate on how many times over the past minute or 2 minutes, let's say, that this host with this AID right here basically went to this remote address on this port. Forget this part here, because these numbers can change every time. The address won't change so much, but the local port might be something different every time. So let's just aggregate on port 53 and for this IP address from this host. That's exactly what we're doing with this native aggregation group over here, where we're telling it if the port here, basically aggregate on the port that is the more likely to be the application port, the destination application port. In this case, it's 53. So we've got these aggregation functions here that are doing this behind the scenes. And the result, if we go here now to the out tab, everything's crossed out because we're doing aggregations here. So let's remove show dropped events. And what we have here is now this AID that had this IP address, because that's another field that's also captured, 5 times basically over the aggregation period that it connected to port 53, right? And then same thing down here again. It might be the same. It looks like it is the same set of IPs that are just being repeated. This one is 17 times. And that's just because it's a different time window, right? Different time window that it's being aggregated on. So just think of the reduction that you would have achieved here, but still have the visibility to know how many times somebody's been doing a DNS lookup, but during this time frame. How many times have they been trying to talk to a potential ransomware actor or malicious destination? You can track that all still, just even with doing these aggregations. And in this case, a pretty massive 99% reduction. With this 99% reduction, though, this is native aggregation. Remember, Cribl works on a share nothing architecture. So every CPU, every worker process that's out there is actually going to be doing its own aggregations. It's going to be doing its own aggregations and reporting those findings. To have one aggregation, a stateful aggregation, as I like to call it, that's where the Redis option comes into play instead. And so if you disable this, and notice here, enable group A or B, not both. Right? Enable A or B, not both. So you'll do aggregation via Redis instead of via native. And when you do that and click save, now it's going to be using Redis instead to do the aggregations. And the results will, in this case, I think there's little something I still have to update here. Otherwise, we should have seen a lot more events. And behind the scenes, when you look at what's happening in Redis, I have a Redis instance running over here. It will basically, yeah, maybe it's access to this instance. Maybe that's why. Or these events as well. These events could just be also all, yeah, from this host IP. Time to live right now is 36 seconds. And there's basically, if I refresh this, so yeah, time to live you can see is getting reduced, 15, 12, but this 36, that means 36 times that it's basically seen this combination. And then that gets reflected or would get reflected back into the pipeline here when we expand raw and look at the count field. The count field will basically add count. This one has 100, so one of these other ones has the lower number.
Yeah, Matt. Question for you. If you're, because of this shared nothing architecture, is it better to do shorter timeframes for your aggregations? Or does it matter at that point because you're still going to get multiple events like you were getting? And then would you kind of run that through like a post-processing and then kind of summarize them all or something? How would that work? Or is that same problem again, I guess?
Yeah, if you do a post-processing, it might then just work on that. Well, yeah, well, how would that work? It would work on the node.
Yeah.
It might not, yeah, it might be going to a different worker process altogether. And it's still going to work independent of the other worker processes.
Gotcha.
So it's not going to resolve that share nothing side effect. For that, that's really where Redis is needed to address that.
So I guess the first part of my question then is, is it better to do shorter time frames or longer?
Absolutely.
Either way, you're going to have multiple. It is better because, okay.
Absolutely. Yeah, I have 60 seconds. Originally, in my first version of this, I had this as 6,000 because I was in my testing, but only because I have these limited events. But yeah, 60 seconds is an ideal for native aggregation.
Is that going to be because you're more likely that one process is going to be processing that short amount of time rather than having multiple at the same time, and you're going to have sort of different events from that same period in different processes? It's
really about memory consumption. If you have it more than 60 seconds and you keep aggregating over a longer period of time, your memory, you're going to have more memory that continues to grow and be used. And now not just by one worker process, now multiply that by every worker process that's on the system. So now, if it's occupying, say, 500K of memory for this one aggregation function for one worker process, and you have 14 worker processes, well, now 500 times 14, right? That'll memory, that consumption that it would use. Then I don't know that's how much it would actually be using. Just using that as an example.
Cool. Thanks.
Sure. But after I refine it, Redis is definitely the better option for stateful aggregation if you have access to a Redis instance. All right, so with that, let's just sum things up here. This diagram should be really helpful for anybody getting started with this pack because it draws out exactly what is happening and how it happens. And then further down in the file too, they didn't go cover this, but the instructions. One of the first instructions is to download this event breaker rule set, where once you download it, you can go to knowledge, and not within the pack. You have to go knowledge up at the top level here, and then you'll have event breaker rules. This is where you can add that event breaker rule, and then that's you'll have to associate it to the S3 input that is reading the logs from the CrowdStrike provided S3 bucket. All right, good time to jump to the other pack. Should spend a little bit less time on that one. It's not as involved as this one.
Yeah, Ahmed, while you're switching over there, for a typical customer, right? Valuable logs, definitely a bunch of noise in there as well. What would you expect for reduction from a data perspective? What's reasonable? Keep in context that's needed.
Working with one customer recently, we've seen 56% reduction for their CrowdStrike events. That's with them even turning off the DNS pipeline. They did not want to remove their DNS events based off of the top 100,000 or even top 10. They wanted to keep them. And so even with that out of the picture, they still achieved a 56% reduction.
That's helpful. That's huge. Thanks.
And Ahmed, is it before they start using Redis, or they are aggregating with Redis?
Great question, Igor. That is without Redis. So if they used Redis, the number would actually even be larger because the aggregation would be one aggregation versus one for every CPU that's in the worker group.
Thank you.
Hey, Ahmed, what was the customer quote you mentioned earlier? I might have missed it.
56%. So in this one customer we worked with just last week, 56%.
Okay, thank you.
Looking at these data sets, though, if we just go back here to the top level, so let's go pipelines, CrowdStrike general, and then let's load. I've got two sample sets in here. Sample one, this one, that's not right. Let's see. Why would it do that? These are probably all the network events. That's why. So, okay, now here we go. It didn't update in time. So this one has a 91% reduction. Why? Because it's mostly these network events that get aggregated. This other one here, sample 2. And we'll wait for it a little longer this time. 50% reduction, because this one's a little bit more diverse in the event types. All right, let's move on to Imperva. So go back up here to packs. Here is this Imperva security pack. And for those who aren't familiar with Imperva, they're primarily known for two products. They're web application firewalls. They'll basically sit behind web servers and middleware even, and basically just detect potential malicious activity and block it. And then also database activity monitor, or DAM. And so this sits on the database servers and basically, or in front of the database servers, and helps protect the databases from things like SQL injection attacks. And the kind of logs that they send, let's start with the web application firewall. Web application firewall also is often marketed as Encapsula WAF. So if we go ahead and look at this Imperva WAF pipeline, and let's open up a sample data set here. Looks like we have this one in twice. Let's try this again. The second one, yep. Okay, let's try the second one. Here's what these events look like from the WAF, web application firewall side. These are CEF formatted events. So they have the generic beginning here, and then everything after that is key value paired, which is nice, makes it easy to process, or so you think, because look at, for example, this request client application. It's Mozilla 5.0. Oh, wait, there's a space, which is the same delimiter as between these two key value pairs. So is it really easy to process? Maybe not so. But so here's basically this whole from here. This is the request client application field. And then the other thing that Imperva, as well as just common information or common event format, is known for is use of these CS fields. So CS2 equals true, CS2 label equals JavaScript support. This is really translating to a field called JavaScript support is equal to true. Well, why don't we condense this? let's make that actually say JavaScript support. Maybe replace this space with an underscore or something like that, equals true. Or CO support equals true, and so on. Right? So let's have Cribl do that. And then the other thing that's interesting in these events as well, one of the fields, the request body, I think it's called. Okay, not in this event, but a lot of times there's a request body field that just has this big, massive, crazy URL in there. Maybe you want to keep that. Maybe you want to remove it because it's parts of it are captured in other fields already that are in this event. So some of the things that I do here in this particular pack is, besides the initial cleanups here, some other optimizations, like looking for some redundant fields over here, removing this post body field, which is one that I was talking about that can be pretty large and would be definitely useful in a threat hunting use case. But do you need it every time going in? Maybe you do, maybe you don't. You can turn this off if you find that you prefer to keep that field. After this, we basically here, notice you always have to read the documentation. And here we at least try to document as well what are some of the procedures. So here we're saying enable B or C, not both. So what this here is doing actually is something for Splunk in particular, where some fields are taken and written as index time instead of leaving them inside raw and having them as search time. So if we enabled this and disabled the group C over here, well, before we do that, let's see what the events look like. So this is what the events look like in the case of Splunk, right? They're going to have the necessary index time fields here. We'll add this one and everything else is inside raw. With this, we have a modest 20% reduction in size. But now if we reverse it and enable the group B, disable group C and save, let's see what that does to the results here. Notice there are more fields here that are added as index time. And these can all be searched with T-stats as well to improve your search performance there on the Splunk side. In the case of Elastic, you want all your fields to actually be outside of raw. You do not want to be sending underscore raw to Elastic. You just want all the fields extracted outside of there and sent basically as green fields as we see here. Doing this, even though it adds a little bit here to the reduction, it actually is down less with the -7%. This will add a little bit to the storage, but you would do this for the reason of using the tstats command within Splunk in order to have faster search performance. That is the only reason that you would do this. The other thing that you'd want to do here is go through these fields and ask yourself, are these the fields that my users search on the most? Are these the fields I search on the most? If so, I'm going to keep them in here. Everything else, I'm going to take it out and I'm going to leave it back inside the raw portion of the log. So index timing for purposes of improving search performance, or in case of Elastic, you need index timing for everything with the way Elastic's architecture works. Any questions about this web application firewall? Oh, and if we look here as well, remember the whole CS fields. Notice here now we have CS vid equals this field. We have CS app signature equals this field. We no longer have CS label equals this, CS equals that, right? So there's a little bit of reduction in just ease of being able to search on these fields now just by doing this. And I decided to keep this CS underscore in there just so that it's easy to incorporate whether a field is, originally from a CS label or, a non-CS label.
No questions in the chat.
And then the DAM one here does more or less the same thing, but for slightly different event formats that come out of that data set. Let's go back here. I think there's some of these that, yeah, got to get the right one. There we go. I'm going to look into that as well. But yeah, more or less very similar. All the CS fields will now have CS underscore group in there. There's a group for index timing enabling versus non-index timing, right? That same logic is in there as well. And then same results. This one results in more reduction compared to the other one, slightly more just by doing this. To finish it up, can't emphasize enough the need to look at the README. Go to the settings, it's all in there. Or if you're, in the dispensary itself, when you click on the pack itself, you'll see also the same README in there. So very important to always start with this to just familiarize yourself with the content in there, see what you might want to change, see what you want to keep, and also what are some of the benefits of using these packs.
And one comment from the chat, Ross. This will be recorded up on YouTube in a day or so, so you'll be able to access that on our Cribl YouTube channel. So you'll be able to see the beginning for CrowdStrike that you missed.
Okay, perfect. Thank you.
Yeah, and just to go back to that one, the README in here is even more powerful because of this diagram that explains everything that is going on in the CrowdStrike pack. All right. Any thoughts, questions?
So, Ahmed, in your experience, especially with Imperva WAF, do you think we'll get much benefits from aggregating those events? Are there tons of similar ones?
Yeah, there's something to be said for potentially aggregating by the source host and the URL that they're downloading data from. That's a good use case there. I will look into that. Appreciate that, Igor.
And just out of curiosity, from your experience, what volumes of WAF and DAM data have you seen from Imperva? Like, is it in gigabytes, terabytes?
The two customers that I've worked with that have these, both of them, it's the WAF in particular is easily can easily be several hundred gigabytes to low terabyte range. Especially for customers that do a lot of e-commerce, then the number will definitely be higher. For the DAM, it's fewer customers have DAM, I've found, but those that do leverage it quite heavily. And also similarly complain about some of the data formats and just how tough it can be to filter data outside of those logs. So not as much DAM, but it's still, it shows up often enough to be noticed, for sure.
Makes perfect sense. Thank you.
Great questions. All right. Well, Shane, if there aren't any other questions, we can go ahead and end this. Thank you, everyone, for joining. And we're on the community Slack. If you have any questions or you want to add some capability to one of these packs, feel free to let us know. There's the Cribl Packs channel where we can take that feedback.
Awesome. Thanks, Ahmed. Nice work. Thank you for joining today. And we'll have this recording up soon.